Okay, so if we are keeping a dielectric slab next to the capacitor, the molecules or you can say dipoles will be arranged like this, right?
Yeah.
Yeah. Because they will be arranged in the direction of electric field lines.
Yeah.
As shown here. Now see what will happen. These negative charges and these positive charges will exert a force on each other, right?
So it'll be an attractive force?
Yeah, attractive force, correct. So you can say overall this attractive force here will be in this way.
Yeah.
Right? Yeah. And here attractive force will be this way, right? Yeah. Okay. Now tell me what will be the resultant force of these two forces?
It'll be left and through the.
Left and through the. Yeah, right. So resultant force on the dielectric will be this way, right? Right. So dielectric will be pulled inside the capacitor. Okay. Like this.
Yeah.
Okay?
Yes, it's clear.
Is that clear?
Yeah. Yes, it's clear.
Now, who has applied force on dipole?
Sorry, could you repeat the question?
In this situation, who applied the force on dipole?
I mean the electric field is what's pulling the.
The electric field is what's
I completely agree. I completely agree. You are right. Electric field has applied force on dipole. You are right. Okay. That means the system of two plates, positive and negative, the system of two plates has applied the force on dipole. Right? Suppose this distance is x. Okay. So that average force F into x is the work done by the system, right?
Yeah.
Correct or not?
Correct.
In fact, if you have to take the dipole out of the system now, you have to apply a force in opposite direction. And then you will apply that force, you will do the work, and then dielectric will be out of the system.
Yeah.
Yeah.
So this is the work done, right? Okay?
Yeah.
Can you find this work done? It's really tricky. I mean, it's quite difficult, but if you think like in a very conceptual manner, you may get the answer. Okay, I can give you other things. So D is the separation, A is the area of plate, K is the dielectric constant. What else you need? Nothing. Yeah, that's all you need. Okay. So can you find this work done? It's quite weird because you have no idea about this force which is applied on the dielectric. And X is also not given. Yeah, X is also not given.
Can't you take a voltage
but still I'm
and then
saying
multiply
that you can
by
find
like
this
the
work
charge?
Can't you take a voltage and then multiply by like the charge?
Oh.
But you don't know charge. See, I understand that charge is rearranged like this, but you don't know this amount of charge at all. I mean, this is like very, very subjective. I mean, we have no calculation which can tell you that what is the final net charge caused by the orientation of dipole. It's a very subjective. It's a discussion thing. That's all. I mean, there is no quantitative value or there is no quantitative measurement of the charge. I taught you this long back, like in third or fourth class, which we had long back. Suppose, Arun, let's think in a very, very weird way. Suppose you take your breakfast, and let's say that breakfast has stored, let's say equivalently, I mean, suppose the breakfast has digested, it is broken into glucose, and glucose has given energy to your body.
Okay.
And suppose you have, by eating breakfast, suppose 1000, I mean, just an example, 1000 joule energy. Okay, 1000 joule energy you have got. Okay, now you go on the fourth floor from second floor. From second floor to fourth floor you go, and in this process You do
Whatever,
work
you
of
like
100
the total
joules.
energy minus the work done that
So
you
how
did.
much energy is remaining in your body?
Yeah.
Whatever you like the total energy minus the work done.
Yeah, 1000 joules minus 100 joules, 900 joules, right?
Yeah.
That's exactly the same thing happening here. The system had some energy. When the capacitor is there, positive plate, negative plate, then energy of the capacitor is half CV
Yes.
square. Okay? Half CV square, or you can say half Q square by C. We did this, right? Or half.
Yes.
Okay? So, U, U initial was, when the dielectric was not there, U initial was half QV. Okay? Where Q is the charge in the capacitor. So,
Yeah.
half Q and V is E into D. So, Q is square, Q
Yeah.
by QD by A epsilon naught, right?
Yeah.
So, half Q square D by A epsilon naught, right?
Yeah.
This was the energy in the beginning when dielectric was not there. Now, we have to find the work done here. It's very simple because after dielectric is inside, let's calculate the energy. We can expect that energy should be less after dielectric has gone inside. The reason is this system has done some work. So some energy has been consumed.
Yeah.
Let's see, what is the case, okay? Let's see if the energy is reduced or not. So U final energy will be half QV, right?
Yeah.
Q cannot change because we are not taking or giving charge. So Q must remain same. So half Q and V will be QD by KA epsilon naught because V is calculated by ED and E has become by the same formula K equal to E by E net. So E net equal to E by K. So E by KD. So E is Q by
Yeah.
KA epsilon naught into D, right? So that I have substituted here. So you can get half
UF is more.
Q square D by KA epsilon naught, right?
Oh.
Yeah.
So the UF.
Oh.
Now,
Oh, sorry. Yeah.
UF is more or UI is more?
UF is more.
Yeah, UF is more, okay? UF is more. No, UF is less because the whole thing is divided by K and K is always more than 1.
Oh, sorry. Yeah.
K is always more than 1 or equal to 1. Okay? So when dielectric has gone inside, energy reduces. Now where does this energy go? Whatever energy has reduced, that goes in doing the work in taking that dielectric inside. So now we can calculate the work done. Work done by capacitor will be UF minus UI. So half Q square D by A epsilon naught. Sorry, UI minus UF. Final minus initial. Okay. 1 minus 1 by K. The final answer is
Yes.
work done by capacitor is Q square D K minus 1 by 2A epsilon naught K.
Yeah.
You understand
No.
everything now?
Yes.
Yeah.
Okay. So this is the work done by a capacitor when you keep
Can we scroll down a bit?
next to the capacitor. Okay.
Yeah.
Do you have any doubt in the whole
that's good.
discussion?
Oh.
No.
Okay. You want to copy this?
Yeah.
Can we scroll down a bit?
Yeah.
Yeah, that's good. Oh. Yeah.
Yeah, I sent him a response back, but he hasn't got back to me since. So, yeah.
By any chance, did you get a mail from Arjun?
Yeah, I sent him
response back, but he hasn't got back to me since.
Okay.
So, yeah. Yeah, I copied. Okay. Yeah, I copied.
Okay. I will just tell you summary now. Summary of how things change after putting the dielectric. Okay.
Okay.
So this is the capacitor, and we keep the dielectric like this.
No.
Okay.
Yeah. 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 Yeah.
So let's start with Q. Q changes or
This is
not?
for dielectric.
No.
It'll become E net.
Q does not change. Okay.
Yeah.
Because we are talking about
Yeah.
just an isolated capacitor. In isolated capacitor, charge cannot fly.
Yeah.
So charge cannot change. Okay.
Yeah. Yeah.
Electric field between the plates.
Okay.
This is for dielectric.
Yeah. So what it becomes after putting dielectric?
It'll become E net.
E by
Will
K.
we
You are right.
change?
E by K. Okay.
No.
Yeah.
Where K is the dielectric constant. Okay. So
Oh.
here all the answers you have to give in terms of K. Okay. Like how.
Oh right. Okay. Okay.
V.
Oh.
Yeah.
V becomes V.
What do you call it?
Oh.
Because V is equal to ED. Right.
Oh, right.
And
Okay.
E changes, so
Okay.
V changes. Okay.
Yeah.
I don't know. I
Capacitors.
forget how to express it in terms of K.
KC.
Yeah. Perfect.
Oh, U by K. Okay.
Energy.
What do you call it?
Yeah. Oh, okay. Okay. Yeah. Yeah.
I don't know. I forget how to express it in terms of K.
U by K.
Oh, U by K. Okay.
Because U final
Okay.
equal to half Q into V dash, right? V final.
Yeah.
So half Q and V is V by K.
All
And
right.
half
Okay.
QV was UI, half QV upon K.
Yeah.
So energy becomes U by K.
Yeah.
Okay, understood?
Okay.
So you can see like one quantity does not change. Okay, one quantity becomes K times, and all other quantities become
Divided.
1 by K. Yeah. Okay.
Yeah.
Can I erase this part?
Yeah.
Oh no, I already
You
copied.
should not confuse yourself if the same process is repeated for a capacitor connected to a battery. Okay. So just now I have talked about the isolated capacitor. You want to copy that by any chance?
Oh, no, I already copied.
Okay, fine. Now the same process I am repeating for a capacitor which is connected to a battery. Something like this. This capacitor is there, and then this battery is potential V. And now you are keeping the dielectric
K
of
times C.
dielectric constant K, and it is still connected with the battery. Okay.
Yeah.
Now we will discuss everything again and again. Okay. So first of all,
V
C
by K.
becomes,
Oh.
K times C.
yeah, that won't change because the reason is
Oh.
that simply depends on geometrical configuration and dielectric. So it will
Okay.
be AC no matter it is connected to battery or not. Okay.
Yeah.
Okay. V becomes
V by K.
Oh right. Okay.
V becomes V only because it is connected to a battery. How can V change? See, whatever is the battery voltage, same will become
Oh,
the
right,
voltage,
okay.
right?
Okay.
See, you cannot have a different voltage of capacitor than the battery. Otherwise, it will violate the basic circuit theory.
All right. Okay.
Okay, because what is voltage? They are in parallel, right? So voltage has to be same, no matter what.
All
Something,
right. Okay.
something else has to readjust such that V remains V. Okay. Now, what about
So Q will remain the same, I think. Right.
What about E? What about U? And
Oh.
what about
Yeah.
Q?
So Q will remain the same, I think.
No, Q will not remain the same because here battery can provide charge.
Yeah.
Charge is not isolated. Battery can take the charge or give the charge to make sure
Yeah.
that V remains V. See, Q is equal to CV, right?
Hmm.
Yeah.
Earlier, here Q
Yeah,
was
understood.
V and this C, right? Now later, Q dash will be, C has become KC and V remains
Yeah.
V. So K into Q, right?
Yeah.
Yeah.
KQ. Q becomes
So
KQ.
that'll also be the same.
Understood or not?
Yeah, understood.
Yeah.
Yeah, so K, it
Now,
won't
what
be
about
like
U?
divided by K anymore. It won't. Or,
UI
okay.
is half QV, right?
Yeah.
UF will be how much?
Yeah.
So that'll also be
Oh.
the same. Yeah, so
Yeah.
K, it won't be like divided by K anymore. It won't. Or,
Half KQ because Q becomes KQ, right?
okay.
So it becomes K times half QV, right?
Yeah.
So K into UI. So KU.
Oh.
Correct?
Yeah.
What about E?
So won't E be the same? Because V's equal. Yeah. Yeah, yeah. Yeah.
So won't E be the same because V's equal.
Right.
Yeah, E will be same, right?
Yeah. Yeah.
Correct,
Yeah.
okay. So now you can see here things are different because capacitor is connected to battery, right?
Yeah.
Now can you explain when U becomes KU, when U becomes KU,
The
that
battery,
means
chemical
energy
energy.
is increased by K times.
Yeah.
Okay?
Right.
So who is giving that extra energy?
Yeah.
The battery, chemical energy.
Yeah, perfect. Battery is giving that energy
Yeah.
because battery, as soon as you place dielectric constant, dielectric, then battery gives more charge which flows through the capacitor and gives more charge and energy to the capacitor.
Yeah.
Because C becomes KC, that means it can store more charge. Capacity increases, right? See, C becomes
Yeah.
KC means capacitance has increased. So here, battery will maintain some charge on the capacitor, right? After that, charge will not flow. As soon as
Yeah.
you place a dielectric, then more charge will come to the capacitor such that it becomes KC. It's such that it becomes equal to V again.
Yes.
So it will do some more work. It will add
Yeah.
some energy to the capacitor.
Hmm.
Understood?
Yeah.
So that is the effect of dielectric on an isolated capacitor and on a capacitor connected to a battery. Is that clear?
Yes.
I can erase this.
Yeah.
Yeah. Yeah.
Suppose this capacitor had
Would
capacitance
be
C.
C
Now,
K1
in
plus
half the
CK2.
area you are keeping K1, in half the area you are keeping K2. What is the new capacitance? Hello?
Yeah. Yeah. Would it be C K1 plus CK2?
No, you have to think. It's not right. I have given you 4 options. You can maybe it can help you. Yeah.
Is it D?
And it capacitor region, the region
Yeah.
between the plates, the whole space between the
Mm.
plates can be divided into 2 identical parts. In one part I am putting K1 dielectric, another part I am putting K2 dielectric. And now I am asking what is the new capacitance of the overall capacitor?
I don't know. Can we discuss it?
Is it D? Or no?
Mm.
I don't know. Can we discuss it?
Yeah.
Yeah.
So suppose you have a capacitor like this.
Mm.
If I break it in 2 equal parts and connect like this,
Right.
okay. So if you remember, capacitance is epsilon naught A by D. So in
Yeah.
this case, D remains same because I am not changing D, but I'm taking half plate area here and half plate area here.
Yeah.
Okay. So A
Yeah.
becomes A by 2, right?
Right.
So each of the capacitance will be C equal to epsilon
Right.
naught A by 2 into by D, right?
Yeah.
So it will be C by
Yeah.
2, right? And C by 2, correct?
Yeah.
And they are in parallel.
Yeah.
So C by 2 plus C by 2 is C,
Right.
which makes sense also because it is C. Okay, so you can say that
Okay.
a capacitor you can consider very well. You can consider a capacitor very well as if it is 2 capacitors in parallel, but half plate area. Okay,
Yeah.
Okay.
because they are in parallel,
Yeah.
so capacitance is C equal to C1 plus C2. So it is C again, right?
Yeah.
Now here, suppose you put a dielectric of K1, and here you put a dielectric of K2. So this will become K1 C by 2.
Okay.
Yeah.
This will become K2 C by 2.
Yeah.
Yeah.
So new C will be K1 C by 2 plus K2 C by 2.
Yeah.
So you have K1 plus K2